Right. So now I think it is clear that T, which is clearly pointing upwards, meaning that T is clearly pointing upwards, meaning that a string can only pull. This string cannot push this mass. So while we don't know what is the magnitude of this tension, we do know that it is pointing upwards. Pretty much the same story for M2. The string can only pull M2, it cannot push because the string can only pull. So that is why T is in the upward direction. So therefore, in both the equations, T has got a positive sign and M1G has got a negative sign, M2G has got a negative sign. And all of these is due to this coordinate system where um, clearly this direction, so this direction is positive, y direction, and this direction is negative. So we are being guided by this coordinate system to write down our equations. So at this stage, what you know is that if only we can resolve this mismatch between the number of equations and the number of unknowns, we are able to solve the problem. Once again, this time, like last time, the answer, the third equation, is nothing to do with physics. It has just got to do with this arrangement here of the pulley and the masses. Now, just by clear observation, it is very clear that in this arrangement, if A1 mass 1 goes up, which means that A1 is positive, then mass 2 comes down, which means A2 is negative, and vice versa. So the accelerations of A1 and A2 are related due to this arrangement, which I'm calling the geometric constraint. And even in this problem, the geometric constraint equation is very easy. I just write it down here. A1 is equal to minus A2. Please note the minus sign because that is the way to capture the information that the magnitudes are equal but the direction is opposite, right? And now we know that the observer can definitely claim that the problem is solved. What I'm going to do now is derive this equation